Okay, so the 2017 free response exam for AB, number 6 from the 2017 exam, they give you a lot of different things. They give you a table, right? And the table includes values of G and also G prime of X. They give you a graph of H, which means, and they're line segments, so which means you can find H prime, okay, of different values. And then they give you the symbolic formula for F of X, okay? And so G is a differentiable function. Table above gives values of G and its derivative G prime at selected values of X. Let H be a function whose graph consists of 5 line segments shown in the figure above. Okay, and so what we want to do first is part A, find the slope of the line tangent to the graph of F at X equals pi. Okay, so we want to find F prime at pi, right? That's all we have to do. Okay, so let's go to our paper and we'll do that. So for part A, we know that F of X is equal to cosine of 2x and then plus e to the sine x. Okay, so the very first, before we can find f prime of pi, we got to find f prime of x. Okay, so the derivative of cosine is negative sine. So we have negative sine of 2x times 2, because the chain rule, okay? And then plus, okay, so the derivative of e to a power, right? So that's e to that same power, e to the sine of x, times, this is the inside function, right? So times the derivative of sine x, which is cosine x. Okay, so cleaning this up a little bit, we have f prime of x is equal to negative 2 sine of 2x plus e to the sine x cosine x, right? Okay, so we're going to put pi into this and see what value it gives us. Okay, so f prime of pi. Okay, so that'd be negative 2 sine of 2 pi. 2 times pi, right? 2 pi plus e to the sine of pi times cosine of pi. Okay, 2 pi is right on the positive x-axis, right? And sine is 0 there. So this is all going to get dropped out, okay? So f prime of pi would be equal to negative 2 times 0, right? So which is, I'm going to go ahead and write negative 2 times 0, okay? And then e to the sine pi, that'd be plus e and then sine of pi, well, that would be 0, okay? And then cosine of pi would be negative 1, okay? So e to the 0 is 1 times negative 1. This is negative 1 and this is 0. So f prime at pi is simply equal to negative 1, okay? And that's f prime of pi, okay? So now we need to go to part B. So part B, it says let k be a function defined by k of x equals h of f of x, right? And then find k prime of pi, okay? So we got to figure this one out, right? So this, we're gonna have to use, they're testing you, do you know the chain rule, okay? All right? Okay, so we'll go to our paper and we'll do this one. So we know that k of x is equal to h of f of x. Okay, so that would mean when we take the derivative k prime of x, right? Before we can find k prime of pi, we got to find k prime of x, okay? So k prime of x is equal to h prime of f of x times the derivative of the inside function, so that would be f prime of x, okay? So k prime at pi would be equivalent to h prime of f of pi times f prime of pi. Okay, now from the previous part, we know that this is going to be negative 1, right? But we don't have f of pi yet, right? So what is f of pi? So remember, f of x is equal to cosine of 2x plus e to the sine of x. So f of pi would equal cosine of 2 pi plus e to the sine of pi, and sine of pi would be 0, so this would be e to the 0. Okay, so f of pi would be e to the 0, and then cosine of 2 pi would be 1, right? Because that's the positive x-axis, okay? So that'd be 1 plus, this is e to the 0, and e to the 0 is 1, so this would be 1 plus 1, which is 2. So f of pi is equal to 2, okay? So back over here, that would mean k prime of pi is equal to h prime of 2 times f prime of pi. Okay, so then k prime of pi, h prime of 2. So, okay, so that's the slope for the graph of h at 2. Okay, so I'm going to go and look at the graph of this. Okay, so at 2, okay, at 2, what's my slope here, right? Right here at 2, well, from here to here, I'm going down 1 and right 3. So that'd be -1 and to the right 3. So that the slope is -1/3. This derivative anywhere on here would be -1/3, okay? So h prime of 2 would be -1/3. F prime of pi from above, we know that's -1. So that would mean k prime of pi must equal 1/3, okay? And that's the correct answer for part B. Okay, so for part C, let m be the function defined by m of x is equal to g of -2x times h of x, and then we want to find m prime of 2, okay? So we got to realize, okay, this is a product, right? So here we have a product, so we're going to have to use the chain or the product rule, but then within the g, we have an inside function of this -2x, right? So we're going to have to use the product rule, and within the product rule, we're going to have to use the chain rule, okay? So let's go to our paper and we'll do that one. So for part C, we know that m of x is defined as g of -2x times h of x. Okay, so then m prime of x, we would have to find that first, okay? That'd be the derivative of the first function. So the derivative of g of -2x would be g prime of -2x times -2. I'm going to put parentheses around that, times h of x. Okay, and then plus. Okay, the first function left alone, so that'd be g of -2x times the derivative of h, so that'd be h prime of x. Okay, so cleaning this up a little bit, okay, so m prime of, and let's say, what were we trying to find? M prime of 2. Okay, that'd be equivalent to finding g prime of -4 times -2, h of 2, plus g of -4 times h prime of 2. Okay, so m prime of 2 would equal g, let's write -2 first. So it'd equal -2 g prime of -4 times h of 2 plus g of -4 h prime of 2. So m prime of 2 would equal -2. And then what is g prime of -4? So g prime of -4, they're telling you, reading off the table, g prime of -4 is -1. Now we have to find h of 2. Okay. So we have to go to our graph, okay? So we know, okay, right here, this point is 0, 0, okay? And we know we go down, okay, 1/3, right? Okay, so that would mean this is 1/3 right here, and this would be -2/3. Okay, so this would be -1/3, because every one I go across, I'm going to go down 1/3, right? Down 1/3, down 1/3. And by the time I hit to 3, I've gone down a whole, right? That's why this is landing right here at -1, okay? So since the slope is -1/3, I can go down 1, right I can go down a third and write one, down a third and write one, and then that would put me right here. This point right here is h of 2, and it would equal negative 2 thirds, okay? All right, just like h of 3 would equal negative 1, okay? And h of 1 would equal negative 1/3, okay? I may have said that wrong. H of 3 would equal negative 1. I think I said 1, okay? All right, in my mind it's right, okay? Okay, let's go back and let's figure out these values. Okay, so h of 2, what we just figured out was that is negative 2 thirds plus, and now we got to look up g of negative 4, right? And g of negative 4 is 5. And I'm just looking at my paper, okay? And then h prime of 2. Okay, so the h prime of 2, right? We just did that in the previous problem, okay? H prime of 2 is the slope right here. Well, what do we know about the slope? It's 1/3, right? So this would be 5 times 1/3, okay? So m prime of 2, you wouldn't have to keep writing m prime of 2 as long as you kept the equals going, okay? This would be negative 2 times negative 1, that'd be 2, times negative 2, that would be negative 4 thirds. So we have negative 4 thirds and then plus 5 thirds. And negative 4 thirds plus 5 thirds is 1/3. So m prime of 2 is equal to 1/3. Okay? You guys, I just made a mistake. I just realized. I just said, frustrating. Back here, back up. Okay. H prime of 2 is not, the slope is not 1/3. It's not going up. It's going down, right? This should be a slope of negative 1/3. That changes this. That makes this negative 5 thirds, right? Okay. My explanation was right. I just wrote the wrong number, okay? And then negative 4 thirds minus 5 thirds, it would be negative 9 thirds, right? So let me change this. I'm mad at myself right now, okay? So this is negative 9 thirds, which is equal to negative 3. Okay, now I'm going to tell you the truth. If I were doing this on the AP exam, yes, I would lose the answer point, okay? But making that mistake right there, I would get almost all the points on this problem. I'm looking at it, and yeah, I mean, it's a 3-point problem, okay? And honestly, I would have gotten 2 out of the 3. And so that's not bad, okay? All right, if you do 2 out of 3, you're doing good, all right? Okay? All right, so let's go to part D. Okay, so is there a number C in the closed interval -5 to -3 such that g prime of C is equal to -4? Is there a derivative in between -5 and -3 such that you would have a derivative at -4? So what I would tell you to do is, since this is a closed interval, right, and they tell you g, because it's about g, right, g is a differentiable function, automatically, if g is differentiable, it must be continuous, right? So if it's differentiable, it has to be continuous. That means it has to be continuous on -5 to -3 closed interval. It also has to be differentiable on the open interval -5 to -3, okay? Because it says it's differentiable. And then you'd have to find the average rate of change between these. And then if it comes out to be -4, okay, then there has to be a derivative that's -4, okay? That's the way I would do it, okay? And if you look, let's just kind of eyeball it, okay? So -5 to -3 would be these two right here, right? Okay, so that would be, I'm going from -5 to -3. That's an increase of 2, okay? And 10 minus 2 would be 8, right? The difference between these is 8. The difference between these is 2, and 8 divided by 2 is 4, is negative, I'm sorry. 10 minus 2 is 8, and -5 minus -3 would be -2, right? Which would give us a derivative of -4, right? We'd have an average rate of change of -4. That means we'd have to have a derivative that's -4, okay? So what I was saying works, okay? All right? Okay, so let's formally write this up in part D. Okay, so from the very beginning, we said that G is differentiable, right? G is a differentiable function. Okay, by them saying that, we know that G is, or g of x or g is continuous on the closed interval -5 to -3 and differentiable on the open interval, and this one has to be open, -5 to -3, okay? And, okay, we're going to do this. G of -3 minus G of -5 over -3 minus -5. Okay, so from our table, what is G of -3? And that is 2 minus G of -5. And if we look at our table, that's 10 over, this would be -3 plus 5, right? Okay, so 2 minus 10 is -8. -3 plus 5 is 2. Dividing those, you get -4. Okay, so between -5 and -3, the average rate of change is -4. There has to be a derivative, and this is the mean value theorem, okay? All right, so by the mean value theorem, there must be a C, comma, now where is C? It has to be in between -5 and -3. So -5 less than C less than -3. Now you can't include these, okay? Okay, comma, and what do we know? That if we put this C value in, we're gonna get a derivative at that C value that is -4, okay? So by the mean value theorem, there must be a C, and the C is located in between -5 and -3, such that G prime of C would have to equal -4. Okay, now if you leave off the such that, that's okay, okay? But you have to include the continuous part and the differentiable part and the average rate of change. In fact, that's a point, okay? If you're doing this average rate of change, they're giving you a point for that, okay? And then the justification by the mean value theorem, there must be a C, okay? And then you got to locate the C. Okay, now you could say there must be a C and take out that parenthesis, and you could say in parenthesis -5 comma -3 in that interval, right? With, and then you could say something like with G prime of C is equal to -4, okay? Or such that G prime of C is equal to -4, or in there, and G prime of C is equal to -4, okay? You got to just restate that, okay? And I just realized you guys can't see this. Dang it. Okay. All right, so by the mean value theorem, there must be a C. C must be in between here. Can't be at the endpoints. Cannot happen, okay? The mean value theorem says that can't happen, okay? All right, so it has to happen in between somewhere. All right, that's it, guys. That's it for 2017. Question number 6. I don't think this one's that hard, okay? I think this is something that, it's very plausible they could ask you something like this because they ask you, okay, so this is not a textbook problem. And what you had to do, you had to know the chain rule, you had to know the product rule, you had to know the mean value theorem, you had to understand what the slope of a line tangent to the graph, what that means, okay? The slope of the line tangent to the graph at a specific x value. Okay, all of these are kind of fundamental things, but they're not straightforward textbook problems, okay? So I really think this is a good type of question for this year's AP exam, okay? All right, so let's go to let's go to the 2019 exam, and I want to do number 6 on that one, okay? Question number 6 from the 2019 free response exam for Calc AB deals with 3 functions, f, g, and h, okay? And they give you some different information. They tell you g of 2 and h of 2 is equal to 4. The line y equals 4 plus 2/3 times the quantity x minus 2 is tangent. Okay, so this is going to be important, is tangent to both the graph of g at x equals 2 and the graph of h at x equals 2. Okay, so this line is tangent at both at that point. Okay, and then and then part A, find h prime of 2. Okay, so if this line right here is tangent to the graph of g and at h at x equals 2, then whatever slope we have for this line at x equals 2, which is what we have, right? Then that would mean that that's the derivative, right? So you look at this and it's in point slope form, right? A little out of arrangement, but that 2/3 right here is the slope, which means h prime of 2 is equal to 2/3. That's it. That's all you had to do, okay, for part A. All right, so let's go to our paper and we'll record that. So h prime of 2 is the slope of the line tangent to the graph of h at 2, and we have the tangent equation, right? And so the slope of that's 2/3. So this derivative is also 2/3. That's all there is to it, okay? Let's go to part B. And you know what? I should say this. You know what? I should have said this a minute ago. I am not doing 2019 AB number 5, and you may be wondering, like, why didn't he do number 5? I thought he was going to. Number 5, they're not going to ask you this year. It has to do with area and volume, and that's a topic we're going to cover after the AP exam, okay? And it's for those of you who feel like you're going to pass the AP exam, or you feel like you passed the AP exam and you're planning on taking second semester calculus in college. You need to have this, okay? If you're going to repeat it, you don't have to do the work, okay? Because you're going to see it again, all right? You're going to see all that, okay? So I just want to make sure you understand that, okay? So let's go to part B now for 2019 AB number 6. So number 6 on part B is let A be the function given by A of x is equal to 3x cubed times the function h of x. Write an expression for A prime of x and also find A prime of 2, okay? We got to use a product rule, right? That's all we have to do, product rule. Okay, so let's do part B. So we know that A of x is equivalent to 3x cubed times h of x, right? Okay, so that would mean A prime of x would have to equal, okay, so the first function is this 3x cubed function, and the second function is h of x. So the derivative of 3x cubed with respect to x would be 9x squared. So we have 9x squared times, and I'm going to put times h of x plus the first function, which is just 3x cubed times h prime of x, okay? And then they want you to find this at 2, right? Yeah, a prime of 2. So a prime of 2 would equal 9 times 2 squared times h of 2 plus 3 times 2 cubed times h prime of 2, okay? So a prime of 2 is equal to, okay, so 2 squared is 4, and then 4 times 9 is 36. So this would be 36 times h of 2 plus, and then 2 cubed would be 8, and 8 times 3 is 24, times h prime of 2. Okay, so h of 2 we got to know, and we have to also know h prime of 2, right? H prime of 2 we have, right? We figured that out. Now I want to say something. Let's say you wrote the wrong number here. Okay, then in this problem you're going to get the answer points if you used, okay, for h prime 2, if you used an incorrect value but you use this one, right? You wouldn't get the point for this one, but then you can get the point for this one because you're using it properly, okay? All right, so a prime of 2 would equal 36. They told us at the very beginning that g of 2 is equal to h of 2, which is equal to 4. So this is 4, and then plus 24 times, okay, 24 times h prime of 2, which is 2/3, right? Okay, so 36 times 4, so a prime of 2 is 36 times 4. Okay, 6 times 4 is 24, and 30 times 4 is 120, okay? So this would be 144 plus 16, okay? Because 3 goes into 24 8 times, and then 8 times 2 is 16, okay? And then adding 6 to this would give me 150, and 10 more would give me 160. So we have a prime of 2 is equal to 160, okay? And that's the answer for part B, okay? Let's go to part C. So for part C, they give you the function h, a formula for it, right? X squared minus 4 over 1 minus f of x, brand new function that we're first time talking about is f of x in this problem, okay, cubed for x not equaling 2, okay? It is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Okay, so that means if we try to do the limit, we're going to get 0 over 0 or infinity over infinity, right? Okay, and then because that would allow us to use L'Hopital's rule, okay? And then use the limit as x approaches 2 of h of x to find f of 2 and f prime of 2, okay? So let's go ahead and do this. Okay, so there's a connection that you need to make here, okay? And it's this, okay? If we take the limit as x, we're trying to find this. The limit as x approaches 2 of this function h of x, right? And that would be equivalent to the limit as x approaches 2 of our function, right, h of x, which is x squared minus 4 over 1 minus parenthesis f of x, close parenthesis, cubed, right? Okay, now if you try to do 2 in here, right, you're gonna get this to be 0, right? Which means that the limit as, well, let's just do it. The limit as x approaches 2 of x squared minus 4, we know that one's going to come out to be 0, right? Because we can do a direct substitution. That would mean that if I put 2 in here, it would also give me a 0 because if the top's 0, the bottom has to be 0 too, okay? So now I know that the limit as x approaches 2 of 1 minus f of 2, because I'm putting 2 in, right, cubed must equal 0. Okay, it has to, because we're going to get 0 over 0. How do I know we're going to get 0 over 0 and not infinity over infinity? Because the top became 0, okay? All right. So now then, okay, so we can use this fact, okay? Actually, I should put x here, not 2. Sorry, let me fix that. That should be an x. Okay? So because I haven't put the 2 in until I've done the limit, okay, that's why. Okay, so this tells me that 1 minus f of 2, here's where I can do it without the limit, right? Okay, cubed is equal to 0. Okay, so that would mean 1 is equal to f of 2 cubed, right? I could cube root both sides, okay, and that would give me 1 is equal to f of 2. So I now know f of 2 is equal to 1. That's one of the things I was being asked to solve for, right? I want to find f of 2, and I also want to find f prime of 2, okay? All right, now I want to talk about this. We have to know what this equals, okay? So now, because this is 0 over 0, okay, so this is going to be equivalent to the limit as x approaches 2 of the derivative of the top, and the derivative of the top would be 2x over, okay, and the derivative of the bottom, well, the derivative of 1 would be 0, right? So we're going to bring the power down, so this would be negative 3 parenthesis f of x squared, right, because we have to drop the power by 1, times the derivative of this inside function. So that'd be times f prime of x. Okay, now if I do this limit, right, I know this is the top is going to come out to be 4 because 2 times 2 is 4. And the bottom is going to come out to be negative 3. I should put equals here, okay? Negative 3 times f of 2 squared times f prime of 2. This is a hard problem, by the way, okay? F of 2 right here, we just figured out. It's 1, right? So this is 1 squared, which is 1, times negative 3. So this right here is negative 3. So I know this is equal to 4 over negative 3 f prime of 2. Okay, so here's the problem. I've got to figure out what this is equal to in order to figure out f prime of 2. So we got to backtrack. Okay, so this is equal to this this is equal to this, this is equal to this, this is equal to this. What is the limit as x approaches 2 of h of x? Well, at the very beginning, it says functions f, g, and h are twice differentiable, which means they're continuous. And if they're continuous, the limit as x approaches 2, I'm going to write this. Okay, so let me say this. H of x is differentiable. Let me slide it up a little bit. H of x is differentiable, which tells you h of x is continuous. It has to be continuous. If h of x is continuous, what does it mean to be continuous? It means that h of 2 exists, the limit as x approaches 2 of h of x exists, and they are the same, which means the limit as x approaches 2 of h of x must equal h of 2. And we know what h of 2 is. It's 4. Okay, so what the heck? That means that if you backtrack it, right, this is 4, which means 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 this has to equal 4. All right, so I have 4 over negative 3 f prime of 2 is equal to 4. I could multiply both sides and by negative 3 f prime of 2, and I would have 4 is equal to negative 12 f prime of 2. Then divide by negative 12, and I'd have f prime of 2 would have to equal 4 over negative 12. That reduces, so f prime of 2 must equal negative 1/3. Okay? And that's the answer to f of 2 and f prime of 2. Okay? Now, I think it's pretty easy to get f of 2. I think that's fairly straightforward. I think finding f prime of 2 is you got to make this, you had to have made this connection that it's continuous and therefore this limit is equal to 4. Because we could get down to this, but then we have to figure out what it's equal to solve it, right? We don't know what it was equal to. And so you had to make that connection of, oh, it's equal to this, and that because h of x is continuous is the same as the function value at 2, which is 4. Okay. All right. So I'd be really, really happy if you got this part of the problem. Okay. And so let me tell you a little bit. Okay. So if you did this part of the problem, that got you a point, and you had f of 2, that's a second point. This is a 4-point problem. And then you did L'Hopital's. So you applied this, right? Which I think is pretty easy. Okay. That's 3 out of the 4 points. Okay. The connection you needed to make is just a 4th point. So that's what they try to do is they're trying to pull the math out of you as much as you know. And because, I mean, you knew the math, you just didn't see that special connection that you had to make, right? That's usually only like a point, okay, that to make that special connection. And it's not every problem you have to think and go, oh, make that connection between that this was the same as this, right? And then this was 4. Okay. All right. So let's go to part D on number 6. So for part D, they give you they tell you about the functions g of x and h of x. They tell you that g of x is less than or equal to h of x. For 1 is less than x less than 3. Okay. Let k be a function defined satisfying g of x is less than or equal to k of x, which is less than or equal to h of x. For 1 is less than x is less than 3. So k of x is sandwiched in between these two functions, right? And they're asking you, is k continuous at x equals 2? And then justify our answer. Okay, so we gotta find what is k of 2. All right, what is the limit as k approaches 2 of k of x, right? And then show that those are the same, and then we would know if k is continuous at x equals 2 or not, right? We got to show the limit exists, the function exists, and the limit and the function values are both the same. Okay, all right. So let's go to our paper and let's do this one. Okay, so we know g of 2, right, is equal to, and we know it from above, it's 4, right? And we also know that h of 2 is equal to 4, right? Okay. And then we also know that g of x is less than or equal to k of x, which is less than or equal to h of x, for 1 less than x less than 3, okay? So we're doing this all at 2, so 2 is in between here, right? Okay, so that would mean that g of 2, because 2 is in between 1 and 3, is less than or equal to k of 2, which is less than or equal to h of 2, okay? And g of 2 is 4, which is less than or equal to k of 2, which is less than or equal to 4. Okay, so if k of 2 is between 4 and 4, k of 2 must equal 4. Okay, so therefore, k of 2 is equal to 4. Okay, because k is sandwiched in between, right? And g of 2 is 4 and h of 2 is 4. It's somewhere in between. Well, they're the same value, right? So k of 2 would have to be the same value as g of 2 and g of 4. Okay, all right. Now we got to establish the limits, right? Okay, all right. So we know that the limit as x approaches 2 of g of x is equal to g of 2, which is 4, right? Okay, why? Because g is continuous, okay? So these have to be the same, okay? And we also know that the limit as x approaches 2 of h of x is also equal to h of 2, which is equal to 4, okay? And, okay, we know that g of x is less than or equal to k of x, which is less than or equal to g of x, right? So we would know that the limit as x approaches 2 of g of x would have to be less than or equal to the limit as x approaches 2 of k of x, which would have to be less than or equal to the limit as x approaches 2 of h of x. And so this is the sandwich theorem, okay? So since these two are both 4, right? Again, and this is sandwiched in between, right? Okay. Then therefore, okay, therefore, by the sandwich theorem or squeeze theorem, okay, you could say squeeze theorem or sandwich theorem. The limit as x approaches 2 of k of x must also equal 4, because this limit is in between 4 and 4. Well, if it's between 4 and 4, it's got to be 4, right? Okay. All right. And then we know, okay, so therefore, and well, we know that the limit is 4 as x approaches 2 is 4, and we know the function value is also 4 at x equals 2. So or let's say this, let's say the limit as x approaches 2 of k of x must equal 4, right? Or f of 4, or f of 2. Let me write f of 2. Okay, and this is not f. Sorry, guys. It's getting late in the day and I'm getting tired. Okay, so this is equal to k of 2. Okay? So if the limit and the function are equal to each other, if the function value and the limit as x approaches 2 of the function are equal to each other, that establishes that they are continuous, okay? Therefore, k of x is continuous at x equals 2. Okay, guys, and that was part D for question number 6. That's it. We're done with AP review, guys. That is it. Okay. I, you wouldn't know. Well, I was going to say you want to try to do this before the AP exam on Tuesday, okay? But you guys are going to do fine, okay? Absolutely fine, okay? And I'm just happy. I'm happy you guys took calculus. I'm proud of you. I'm really proud of the way we've responded over the last few weeks, okay? Just hang in there, guys. Just hang in there. Do your best, and I'm one happy teacher with a smile on my face, ear to ear, if you just do your best, okay? Okay, that's all I ask. Just jump in there and just do your best. Okay. You'll hear more cheering from me on Monday and Tuesday. Okay. All right. You guys take care, and I will see you later. Bye bye.